Precision and accuracy. These are different concepts. Accuracy is how close the measured value is to the true value. And precision refers to how close a bunch of measurements are to each other. Consider the results of 3 students who repeatedly weighed a lead block known to have a true mass of 10.00 grams. It's a little tricky to just look at this table of numbers and see what's going on. Scientists use graphs to make numbers more visual. So we could graph the data that these students got. Student A, B, and C. So trial 1, we see the height of the line is equal to the mass. And so we look at this and we can see there's a lot of variation in the results. This is imprecise. The values are not close to each other. And if we take the average of those numbers, that's this dashed pink line here, the true value is 10.00. These numbers aren't accurate either. So student A was inaccurate and imprecise. That's bad. 2 undesirable results. Student B, just looking at the graph, we can see all these purple bars are close to the same size. So the student's results are precise. He was consistent, but unfortunately he was consistently wrong. His average, again, the pink line here, is lower than the true value of 10. So although his results are precise, they are inaccurate. And then student C nailed it. Okay, so the purple bars are similar in height. They're very close to each other. So that's precise work. The values agree with each other. And it's accurate because the average is only a smidge above the true value. 10.01 versus 10.00. There are 2 main kinds of error that can cause inaccuracy or imprecision. There's random error and there is systematic error. Random error has an equal probability of giving you a result that's too high or too low. The nice thing about random error is if you take a bunch of measurements and average them, the random errors will cancel out. And that is why we often make multiple measurements. We're going to do experiments where we do 4 trials instead of just 1. Because there is some random error, and by averaging 4 results, we can get rid of the random error. There's also systematic error. And that's error that tends to be too high consistently or too low consistently. If you're at the store and you're going to buy some bananas and the checker at the register has her thumb on the scale every time she weighs your food, well, the scale is going to read high every time. That's a systematic error. If your balance isn't calibrated correctly, if you're reading the top of the meniscus instead of the bottom of the meniscus, these are examples of how you could come up with a systematic error. That's going to affect the accuracy of your results. It may affect the precision, but it will definitely affect the accuracy. Any questions?